With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The given question is the transfer characteristic curve of a transistor having input and output resistance as 100 ohms and 100 kilo ohms respectively, as shown in the figure. The voltage gain and the power gain are respectively. Okay, so we have to find the voltage and power gain, and these are the given options we have. And we are given a graph, a transfer characteristic curve of a transistor, that is IC versus IB graph. Okay, where IC is the collector current and IB is the base current. So from here we can see that the IB we had taken as our input and IC we are taking as our output. Okay, and this is possible only for common emitter configuration, right? Configuration. And now see, the IC is in milliamperes and IB we are taking in microamperes, so there is definitely is a gain happening. Okay, now in the first part we have to find the voltage gain. So we know that the voltage gain is represented by AV and it is given as delta V naught divided by delta Vi. Okay, now delta V naught we can write as, where V naught is the output voltage and Vi is the input voltage. Okay, and delta V naught we can write as delta I naught into R naught. Okay, the change in output current multiplied by the output resistance divided by the change in input current multiplied by the input resistance. So here we are taking output as the collector current. Okay, so it will be delta IC into R naught whole divided by delta IB we are taking as the input and into RI. So from here we can get the value of AB equals to, now see, delta IC would be, now we have to find the change in the IC, so that is 10 minus 5, so it would be 5 milliamperes, right? So we can convert it by 10 to the power minus 3 whole divided by delta IB must be 200 minus 100, that is 100 only, multiply by 10 to the power minus 6 because it is given in microamperes, multiply by the output resistance is given to be 100 kilo ohms, that is 100 into 10 to the power 3 whole divided by 100 ohms is the input resistance. Okay, so now from here we can cancel out the terms, so this 100 will cancel out and we will get AV equals to, this will form 0.05 into 10 to the power 6, or we can write it simply as AV equals to 5 into 10 to the power 4. So this is the voltage gain, okay, for the given transistor. Now next we have to find is the power gain, so that is we can write as, so the power gain we can write as AP, that is equals to the change in delta V naught divided by delta Vi multiplied by the change in output current versus divided by input current. So that we can write as, see, delta V naught by delta Vi we just have found is equals to 5 into 10 to the power 4, and further we can write as delta I naught by delta I input, we can write this value. Okay, so this is 5 into 10 to the power minus 3 whole divided by 100 into 10 to the power minus 6. So we will solve this now. So we will get power gain equals to 25 into 10 to the power 4 minus 3, that is 1. Okay, 1 plus 6, that would be 7. So 10 to the power 7. So now we can write from here the power gain must be equals to 2.5 into 10 to the power 6. So this is the required power gain of the transistor. So from the given options we have A, B, C and D. Option A is the correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.